Hi, I'm Glina, creator of the Micro System 1 computer kit. It is the kit computer that you learn to build yourself, running a virtual world that you build with your friends. So I talked about the computer in my first video and said that I'd designed the hardware myself and written the software myself. I also said that I was going to release the source code for the software, which I now have, and it's up on my GitHub. So the software runs on the computer, on the hardware that I've just shown, but you can also compile it to run on other platforms. For example, I run it under Linux in order to develop it and debug it. So what I'm going to show in this video is how you can get that software set up under Linux. So both the client software, which is the thing that lets you play the game and shows you the world, as well as the server software, which you can run standalone. This will be the first of my chill videos, where I've got a hot chocolate and my marshmallows, which I'm going to enjoy with you as we go through this, get this software set up, and hopefully you'll learn a thing or two about databases, about compiling software as we go along. So I've got my Linux virtual machine running here, which I've set up a virtual machine so that I have a clean install of Linux. In this case it's Debian, and I'm running XFCE as my desktop. I also have here my very special hot chocolate and marshmallow camera so that you can see how I'm going with my snack and my beverage. I'd suggest that you can go and get a beverage of your choice and a snack now and enjoy doing this with me. So first off, I'm just going to get into Firefox and I'm going to bring up my GitHub repository and we're going to download the source code. So it is github.com/lglina, LGLINA/microsystem. So, and given that this is a clean install, we're going to be setting everything up from scratch. So I think the first thing I'm going to do is we need to see whether we actually have Git on this virtual machine, which we do not. So the first thing we're going to do, given this is Debian and it's an apt-based machine, I'm going to go sudo, which allows me to have super user privileges on the machine. So to install software, we need to have kind of elevated privileges. And I'm going to do apt, and I'm going to go install git. I'm going to have to put in my password. This is my user password. And then once my privileges are elevated, apt is going to say, yes, we're going to install git. Actually, to be honest, the first thing that we should probably do, probably jumping the gun here, the first thing we really should do is do an apt update. And the reason that we want to do an apt update is that's going to go out to the internet, it's going to go to the Debian package servers and say, what are all of the latest versions of all the packages that you have available. So that's kind of important. So after we've done that, then we can do our apt install git, and we continue yes. So that's going to bring down git for us. So the next thing that we're going to do, I don't think that we have any build tools on this machine, so we're going to need to install a compiler to actually compile the source code into object code, which is something that the machine can run. So, but maybe again we're jumping the gun. Let's just get down a copy of our software here first. So if we click here under code and we use HTTPS, so we'll just copy that URL to the clipboard. Now we're going to do a git clone and we're just going to paste that in. So what git clone is going to do is it's going to allow us to get a local version of that repository. So repository is a place where you store source code and it can be shared with other people. We're going to make our own local copy of that we can work on. So we're going to clone. Now we can see we've got a new directory called Micro System, CD, just to change into that directory. And there we go. So we've got the different directories in here. The operating system for the microsystem, the Microsystem 1, the computer kit, it's actually called Agape. That's the code name. So why Agape? That's one of the, if you know your Greek, it's one of the Greek words for love. And I think it's about, for me, I talked in my first video about creating a system where you can have your own social network that you kind of run with your friends, and it's a private, secure, personal space. But I think it's also about creating spaces online that are nicer spaces, kinder spaces, where we can show a bit of love toward each other, which is perhaps needed in our world at the moment. So agape, the spirit of a higher love, not love necessarily for one's family or one's group, but for everybody. So we've got the Agape directory, which has got the main kind of operating system for the computer. And we've got a few other ones here. The most relevant ones are Carlo and Linda 2. Carlo is the programming language that I've written that works within the microsystem environment. Linda 2 is called a coordination language that manages how things are sent and received on the network. And Stratus, which is actually the server component. Yeah, it's a joke. Stratus is a type of cloud. I know, very funny. So we're mainly going to focus first, I think, on, let's see whether we can actually get Stratus compiled. So we go into Stratus. We're going to list that out there. So what we'll see in this directory is the important thing is makefile. So what this is, actually, we have a look at it. We actually do have the Nano text editor installed on this machine. That's good. So this actually goes through all of the different source files that make up the software, and it gives instructions for the computer to sort of tell it how to compile those source files. So it's saying we're going to use to compile a CPP or a C++ source file into a .o, an object file, that we're going to call CXX, which is our C++ compiler, and we're going to pass some flags. And this is very esoteric syntax. You don't really need to know it all, but effectively, or at least you can learn it in future. But to compile something using a makefile, we would usually go make. We're going to go make command not found, all right? This is because in a default install of Debian, we don't have any of our build tools. So I believe that there's a meta package that we can install. I think it's build essential. So let me go sudo apt install build essential. I cheated there. I actually hit tab and it auto-completed it for me. It knows that there's actually a package called build essential and it's typing the remaining characters for me. So this is kind of a poor man's AI. So we're going to go yes. It's going to say that we're going to download 63 megabytes of files and we're going to then install into 248 megabytes of space, which is fine. So some important things we're getting here is GCC, which is the compiler. That's a C compiler, GNU C compiler. G++, which is the GNU C++ compiler, and make, which is going to actually be able to run our make file to actually do the build process for us. So we're going to go yes to that. Time to have a beverage while we're waiting. Right, so that's now installed. Let's see whether we can do make. Okay, it's going. Now it's going to fail because there are some libraries that we need to get the server component to compile. So the first one that we're going to need is MongoCXX. Now what this is, the server component, it's got to store all of the information about the virtual world somewhere. So all of our sort of scenes, which are kind of screens where we've got things laid out, all of our assets, which are our artwork files for things that we build, that's all got to be sort of stored in a database on the server somewhere. So the database that I'm using for this is called MongoDB. So MongoDB is a kind of so-called document database. There are a lot of different kinds of databases that are good for different things. You might be familiar with kind of SQL databases where everything is in a kind of table format and you have columns and you have rows and you have keys. It's a very kind of structured, highly structured data. MongoDB being a document database, it's a kind of unstructured data. And I'll show you an example of that later on. So we're going to get MongoCXX, which is the C++ interface to MongoDB, but at the same time we'll see what other things we need before we get tripped up. So go back and have a look at the make file. In fact, this could be an entire separate video as actually how to install an IDE or an integrated development environment. We can use a command line text editor like Nano to look at, is it Nano or Nano? Somebody's going to get upset for me saying Nano. I say Nano. I think it's supposed to be pronounced Nano. You can use a command line text editor to look at your source files, but obviously it's going to be better if we can install a graphical editor that lets us see all of our files and lets us sort of use our mouse to cut and paste and things like that. We won't do that now, maybe next time. So we have a look through here. So we're going to need Mongo CXX, which is the MongoDB C++ driver. Also BSON CXX, because BSON is the sort of binary JSON format that Mongo uses for its documents. Also, we are using WebSocket PP. I'm using WebSockets as my communication protocol over the network to allow the client and server to talk to each other. So we're going to need to install that. That's a C++ WebSockets library. There's this thing called CPR. That's used in the cloud server in the microsystem to sort of be able to communicate with my web server to allow us to send email invitations. We're not going to be setting that up just for this local install, but we're probably going to need it anyway because we're dependent upon it. And this thing called ASIO, which is an input-output library, asynchronous input-output, and that's used by WebSocket PP. So let's go and see whether we can find those things. So for a start, and it's worth mentioning too that I'm probably going to get these off the internet as source code and compile them, but for some of these things we may be able to also install packages using apt, which makes our lives much easier rather than having to compile the individual components from source. But I believe with the majority of these we probably are going to want to go and get them and compile them from source, because then we'll have the latest versions and or the correct versions for what's expected here. Right, so let's see whether we can get first BSON CXX and Mongo CXX. So we're going to basically bring up our web browser again. Maybe we can make that a little bit smaller. Mongo CXX. Marshmallow time. Mongo C++ driver, see the new documentation. Where do we actually get the source code from? From GitHub. Yep. So now I believe that there's probably the latest stable release. Let's do it. Oops, we can just paste that in there. Okay. I can't type properly tonight. Let's try again. All right, so we have not much information in there, but we do have a okay, so it seems like we have a CMake file. So CMake is a different kind of system for compiling source code into object code. I don't think we have CMake at the moment, so let's install that. Sudo apt install CMake. Yes. So what we usually want to do with CMake is that we want to go into a build directory and we want to get all of our object code into there so it doesn't get mixed up with our source code. And we go CMake ... And we have an error. MongoDB AWS requires a crypto library. So I think this probably means that we don't have, let's scroll back, we don't have OpenSSL. So the OpenSSL development libraries, I think we can probably install from apt. So authKeyHash, which is a way to actually search the package library, which we should have. We're looking for a package that ends in dev. It's usually the packages that allow you to compile other things, the development packages. grep lets us search within text output. To search for dev. How about libssldev? Okay, let's try CMake again. And that worked. Perfect. All right, so now we can do make. This might take a little while, so again, time for a beverage. Okay, and we're going. It's probably worth saying actually that we can probably speed up the compilation process by doing make-j. The J is going to tell make to actually use multiple cores to compile at the same time. That can really radically speed up compilation actually. You'll probably see me doing that later with the Agape code. And that's now done. So let's try doing sudo. So again, we're going to get super user privileges or elevated privileges. Because now that we've built that, we want to install it. And so to install it system-wide for every user, we need to actually have elevated privileges. So we're going to do sudo make install. And that's putting it in /user/local, you might notice. So usually with things that are installed with the package manager with apt, they're going to go in /user. User local is for software that we've compiled for our own machine and installed on our own machine. So it's stuff that's not standard from packages, it's stuff that we've compiled ourselves and installed. So just to keep it separate from the stuff that the system is installing with the package manager. All right, so we've got Mongo CXX. What was the next thing that we needed to get? And I think that you'll probably find too with Mongo CXX that will have built the bson CXX stuff as well. As you can see there, it's also installed that into user local. So let's go back to Microsystem Stratus. Let's have a look at our make file again. So we've done bson CXX, Mongo CXX. How about we try getting ASIO 1.30.2? So ASIO 1.30.2. ASIO C++ library from thinkasync.com. So the latest stable release is 1.36, which we could probably use. Might be a good idea to use it. But I'm going to get the version that I've been using previously to compile this, which is 1.30.2. So let's see if we can find the older version. It's available. Download. Download ASIO from SourceForge. Okay. ASIO. Seems to be very popular, 1.30.2. So that's stable. It's 2 stable versions back from 2024. And let's grab the... You can grab the tar.gz. The tar.bz2 is a smaller file because it's higher compression ratio, but hey, 3.2 megabytes compared to 4.5 megabytes. I mean, with the internet these days, maybe if you're still on dial-up. Gee, so many ads on SourceForge. Maybe that's another thing that we should do in this clean install is put an ad blocker on Firefox. All right, so we've got ASIO. Let's go and okay, so this requires a bit of explanation too if you're not a Linux expert. So tar is an archiving and unarchiving tool. So what do we mean by that? We mean actually being able to take a lot of separate files and put them into one single file. That's called archiving, and unarchiving is reversing the process. So it's, you know, like zip, although in this case it's tar, which is actually a way of just putting all of the files together in one big file, and bzip2, that's bz2, which is a way of actually making the whole thing smaller. So what we're doing here is we're unbzipping and then we're untarring. So it's probably too much to go into here, but look into tar and bzip if you want to know more about this command. But we're going to extract that. I'm going to go into ASIO. Okay, so this is another makefile based sort of program, but there's going to be a step which is configure that we need to do first. Whenever you see configure, we want to run that first before we do make. Configure is going to actually set up the make system properly, and it's going to tell us whether there's anything missing that we don't have. So this is actually part of a system, I think it's auto make. It's a system for making make files. Just because we like to make things complicated in computer land. And that is done. We don't have any missing dependencies or any problems. I think you can probably see here as well, I don't know whether it tells you, but when we ran configure, it's probably going to default to installing things into user local. If you really wanted to install it in a different place, like in user, you would pass that option to configure. We're going to run make. Let's try make -j for laughs. Oh, that goes so fast. And we're back to the login screen. Did I crash by trying to do make -j? Wow. Let's get back in again. Okay. I don't know what happened there. Let's try that again. We'll try doing make without -j. Now, if we want to see what the make system's doing in the background, we want to see our CPU utilization, we can use top. So that's going to tell us that we've got CC1+, which is our C compiler, or C++ compiler, so that's taking up this much CPU, this much memory. We can see that we've got, I think we've got 4 cores on this virtual machine allocated. We're only using 1 core at the moment. This is the single-threaded compilation. So if I did this as make -j, let's try this again. This is dangerous. This is what caused us to crash out last time. You'll see now we've got 0% idle, and we're using pretty much all the CPU because we're running lots of C++ compilers in parallel. In fact, that's probably too many. We probably really want to only have, say, 4, because we've only got 4 cores. I think this is going to crash us out again. Hey! Okay. Let's try this again. We can pass to make -j the number of parallel processes we want. I think if you don't specify any number, it's supposed to work it out by itself. It seems to have not done that. Maybe this is some confusion with it running on a virtual machine, but let's try 4. And then we're going to, at the same time, we can run top to look at the CPU utilization. There we go. Okay, so we have fewer C++ compiler processes running, which is good. Hopefully this means we're not going to crash out again like last time. Interestingly, if we did sudo dmesg dmessage, we put in our password, there we go. This is actually, this is looking at the Linux kernel logs, and we can actually see why we died before, and it's out of memory. So this is a thing in Linux called the killer, or the out of memory killer. When we run out of memory, then something has to die to free up more memory. So it's actually killed our entire X Windows session. So I don't think it was a situation where we're actually sort of, if you use too much CPU, then the system just becomes very slow, but it's not going to cause your entire desktop to go away. I think it was just that we were running so many C++ compilers at the same time that we actually ran out of memory. We probably don't have any swap files set up on this virtual machine, or actually we do have swap set up on this machine, but not very much. Looks like we've got 2 GB of swap, and we've got 4 GB of allocated real memory. Time for more beverage. Okay, and we're done. So we want to do sudo make install. Now, where has it installed it? I wonder. So it has installed it, I think, in user local. In fact, if we look in user local lib, so we've got lib bson cxx and lib mongo cxx in there as before. Don't know about ASIO. I think ASIO may be one of these libraries where it's headers only. So we can see there that it's actually installed a bunch of HPP files or C++ header files into user local include. Anyway, so that's done. Let's go back to Microsystem Stratus. Let's have a look at our make file there again. So we've done bson cxx, we've done mongo cxx, we've done ASIO, we need to do WebSocket pp, and we need to do CPR. So let's see if we can get WebSocket pp. Thank you to Zaphoid, who wrote this library. I think if we go to tags, all right, so we're looking for 0.8.2, which is this one here from 2020. Let's get it as tar gz. Done. Notice this time, because it's a .gz file, it's gzipped, not bzipped. It's a different kind of compression. So we're doing xvzf instead of xvJF. So eventually you'll just learn these obscure command line flags by heart. But again, I'm using tab to autocomplete because I'm lazy, and there's only one .gz file in downloads, and it's going to be that one. So it'll just autocomplete to that file. And let's extract it into our home directory. There we go. So this is another, how do we compile this? Looks like there's CMake lists. It's another CMake. In fact, I think there are some special instructions for this. Let's look at readme.md. No special build instructions. Let's just try doing mkdir build, cd build, which is the same thing that we've done previously. CMake ... Alright, so let's give it a go. I'm sure that it's found OpenSSL, but we'll try making anyway. Really doing anything when I type in make. Why is that? How do we actually compile this? Okay, so I made a bit of a blunder there. I think I was talking before about the idea of header-only libraries, which seem to be kind of, popular in C++. And WebSocket pp, indeed, it says that it is a header-only library. You can start using it by including the WebSocket pp source directory in your project's include path. So actually, there's nothing that does need to be made. So I think if we just, let's try this again. mkdir build, cd build, cmake ... So make doesn't do anything because there's nothing to compile, but sudo make install installs into user local include the header files that we need. I think I'd mentioned that I thought that ASIO was also a header-only library. I could be wrong, but I think the reason that that needs a compilation step, which appears to do something, I think probably has to do with the way that it uses polyfills. Again, I could be completely wrong, but polyfills in C++ is this idea of that if you don't have a compiler that matches the most modern standards, you can kind of take the modern C++ code and you can kind of munge it into something that will work with an older compiler. Alright, so that's done. Let's go back to... Now there's another bit of shorthand there that I've just used. If you type cd and hit enter, then that takes you back to your home directory. You don't have to type cd, home, whatever. Or alternatively, the other shorthand for your home directory is tilde, but you don't need to do that either. CD will just take you back there. CD Micro System Stratus. Let's have another look at our make file. Okay, so we've got, in fact, WebSocket PP, I'm just including it there from the home directory. So we didn't actually really need to make install that at all. We could have just decompressed it. Similarly, I think with ASIO, we probably didn't need to build that. I suppose if I'm using a modern enough C++ compiler, which I have, and you can see here we're actually compiling with the standard for C++ 17. We're actually asking the compiler to support all C++ 17 features. So it's actually just going to lift ASIO out of the directory where I've decompressed it. So actually we probably didn't need to install those in user local. Maybe it might be a better idea though to update these to user local such that we're not having a dependency on needing things sitting in the home directory. It seems nicer if we're compiling against things that are installed in user local rather than just sitting in a user's directory. But anyway, the only thing that we now need is CPR, so, which I think is, we just search for CPR library. So it's curl for people. So a bit of explanation here. So this is about the invitation functions in the server. It has to send a request out to the web server to ask it to send an email, which allows you to invite more people into your world. We do this by using a thing called curl, which is a library that can make requests on websites. But the actual library itself can be a bit esoteric. So I think CPR, it says, it's a simple wrapper around libcurl. So, however, it's far from simple. Okay, well, anyway, let's just get this and install it. So, which version do we need? We want to look back in Makefile again. It doesn't say, let's just get the latest version. I guess we're not being reliant on a particular version. Let's just get whichever the latest is. So what are we looking at? 1.12.x, which is supported. We look on tags. 1.12.0, let's get the tar GZ. Done. Oops. Okay. Alright, so how do we compile this? This looks like another CMake. It's always good to just check whether there's any instructions that they've put on the... Let's have a look. CMake. So we don't already have a CMake project. So I think that the way that I've built this before is just as a sort of standalone library. So static and shared. So I think a static library is where you have a library which is compiled into your program that you're building, whereas a shared library means that the library sits as a separate file on the machine and it's actually picked up at runtime. I think I've previously built this as a shared library. I think that's what we want to do. So let's see, we've cloned it, we've actually untar GZ'd it. So we want to do again mkdir build, cd build. And we want to, let's copy this. So I think where it's use system curl, that means that we can actually use curl as it's already included on our system. Let's just see if it works. Let's try going build shared libs equals on. And it's going to say curl not found on this system, so we could use a built-in version of curl. We could try installing can we get libcurl on this machine? Still doesn't work. Let's just try using the built-in curl. That sounds simpler. Use system curl is off and build shared libs is on. Configuring built-in curl. Beverage time. Okay, so it looks like we have some missing dependencies. Probably best to go back and read more carefully the README in GitHub, because sometimes they actually tell you which dependencies you need. Maybe I'm just being an idiot and not reading that carefully enough. It seems to not be able to find libpsl. Let's get it. And was there another package that it couldn't find as well? Could not find NGHTTP2. I think if we don't have that, it just means we can't support the HTTP2 protocol, but we probably don't care about that. We're not going to be using this functionality in the server anyway. This is just for the cloud version which I run, which you can use, which integrates with my website to allow invitations. If you're going to run a standalone server, then I suppose you could get that functionality to work yourself, but it's not needed. Let's try again. And done, and now let's make. We could try -J4 again. We won't do -J, that's bad, -J4. And that is built, so now let's do sudo make install. I sometimes say sudo, I think it's sudo. So that's now done. So let's try building the microsystem server, Stratus. So now that we've got all those dependencies installed, let's go make. We could do make -J4 to make it faster as well. I think I'm showing you all my stumbles here because this is realistically what it usually takes to compile things, especially under Linux. It's having to make sure that you get all of the dependencies, compile and install those, whether you're compiling from source code or whether you're actually getting dependencies in packages, but there's always a little bit of sort of mucking around or reading or troubleshooting required to make sure that you've got everything in place to compile something. Beverage time again. Oh no, we finished. Okay, maybe no beverage then. All right, there we have it. So we have Stratus. Okay, now it's complaining that it can't find libbeast on CXX. What I'm going to try is, let's try doing sudo ld-config. Now let's try running Stratus. Okay, I think that magic command requires a bit of explanation. So what ld-config does, and again, I'm probably not entirely explaining this appropriately, but we installed a whole bunch of libraries before in user local lib. We look in. So user local lib, we've got the libbeast on, we've got libcurl now, we've got libcpr, we've got libmongo. Basically though, we've built those and we've installed those, but we need to actually update the system's idea of what shared libraries are available. So that's what running ld-config does that. And then actually when you run a program, it can find those shared libraries. So that's a trap for young players. So we have that working. Now, to actually get Stratus to work properly though, I think that we need a couple more things. I think one important thing is that we don't have any keys and certificate. With everything on the internet these days, when we're communicating, we need to be using encryption to sort of maintain our privacy and the security of our communications. So the way that the microsystem client and server talk to each other, as I said, is using WebSockets. WebSockets is a protocol that runs over the same protocol that are used to send web pages. That's HTTP, Hypertext Transfer Protocol. So as part of securing HTTP and other protocols as well, we use a thing called TLS, Transport Layer Security. I just have to catch myself there because it's also sometimes called SSL or Secure Sockets Layer, but I believe TLS is the new terminology. If we're running a server in the real world, we need to get a certificate and a private key from a certificate authority, and this is a sort of trusted authority who can tell the rest of the world that we are who we say we are. Again, I won't go into the reasons for this right now in this video, but you can read up yourself as to how certificates work to secure TLS. But for running our own local server just for testing purposes, we can just generate our own certificate. We will just claim that we are who we say we are, which is ourselves. So let's try doing that now. We can use the OpenSSL command line tool to do that if we have it installed, which we do. So I've got to admit, I can never remember what the command lines are to generate a self-signed key, so we're just going to ask Google. So generate self-signed certificate. So mind you, copying and pasting things from AI into your command line is probably a pretty dangerous thing, but in my case this is just an aide de memoire, and so I can understand what I'm typing in. It's just for my memory. So what we're going to do here is we're going to generate a private key, an RSA key. Now we're going to generate a self-signed certificate. So we're going to do an X509 format. We're going to put out our server key in a file called server.key. Our certificate's going to go out in server.crt, and we're going to have a 365-day validity. Now we just have to enter these details. In our case, can be bogus. Let's just put in AU for the country. Let's say New South Wales. Let's say Sydney. Our organisational name. Let's say Glina Creative. Doesn't really matter. We can just hit enter for these as well. Server FQDN, let's just go localhost. And there we go. So what we'll have now is server.key and server.crt. If we cap those, there is our private key, which usually you would want to keep this private and you wouldn't want to show anybody, but it's okay for this video because of the fact that this is just a key that will only ever be used locally on this computer. Usually do not show anybody your private key. So that's in this X509 kind of ASCII format, so it's base 64 encoded. It's like binary, but it's made in ASCII characters, so we can actually just look at it in a regular text editor. And CRT, so there's our certificate. We can actually look at the certificate, I believe, OpenSSL. Us computer people make out that we know everything and remember everything, but we really don't. We do need to actually ask other people, or we need to Google it a lot. Nobody can remember everything in this business. There is a lot to remember, especially these OpenSSL command lines. Okay, so this one we're getting OpenSSL. We're saying go into a mode where we're going to process X509 formatted certificates, which this is. We're going to go in, well actually it's not certificate.crt, it's server.crt. No out means that we're not producing an output file, we're just going to dump it out to the screen in text. And there is the details of the certificate that we've just generated. Now I'm not sure that those file names are quite correct, because if we look at, we're just going to look in the source code for Stratus for a minute and see what it expects in terms of the name of a key file and a certificate file. So if we just go down to where we're setting up our SSL, we want the certificate to be in cert.pem and the key to be in key.pem. So move that to cert.pem and we're going to move that to key.pem. There we go, and done. Okay, so last but not least, we need to install MongoDB, which is the database that we're going to be using, which I talked about at the start of the video. So I don't think that there are any official Debian packages for MongoDB, so what we're going to do is we're going to install it from the MongoDB website. So if we bring that up now, it's got some steps that we need to carry out here. The first thing that we need to do is, because we're getting it from MongoDB's apt package repository, we need to install their key so that we can actually verify the packages we're downloading are authentic. So we're going to make sure that we've got the tools that we need first, GNU PG, which is a security tool, an encryption tool, and curl, which allows us to download things from the web. So let's try that. We do have those installed already. Let's get the key from MongoDB's website. Now, when we do this, it's going to warn us that, hey, you're copying and pasting something from the web into your console, and you're allowing it to do something with super user privileges, and that could be dangerous because we have a sudo in there. So we're going to say, okay, we know what we're doing. We've looked at that. Yes, we really want to paste that. Let's do it. And that's done. So now we need to be able to set up a file to allow apt to work out where to get the packages from. So we're going to copy that and paste that in, and that is done. We're going to reload the package database, do our apt-get update. Now you notice there that we're getting packages now from deb.Debian.org, which are the standard Debian packages, but now we're also looking for packages in repo.mongodb.org, so it looks good so far. Okay, so now we want to just install MongoDB.org. Sorry, let's try that again. Paste. And there we go, 186 megabytes of archives. So this is a community version of MongoDB. They're actually like paid versions, but this is the free version which we're getting. Time for another beverage. Okay, and that is done. See, MongoDB is suggesting that we change ulimit. We probably don't need to do that straight away. Let's see, something about directories that are being, okay, init system, start MongoDB. All right, with systemctl, let's see whether this will work. So it's going to tell us again that we're pasting something with sudo. Okay, let's have a look at the status, the service, yes, paste. Okay, and it is running. Great. Let's see whether we can run MongoSH. Start a MongoSH session on the same host machine as MongoD. Okay. Yes. Okay, there we go. So there's two concepts here that are important. The first is the notion of like bind address. So what that means is where we are listening for connections that are coming into our database. Now I think by default when we set up a local MongoDB, it's only going to listen to connections from our own computer, which is 127.0.0.1. So that's a good thing because you can actually see the startup warnings when the server started. It says access control is not enabled for the database. Read and write access to the data and configuration is unrestricted. So you would not be wanting to put this on out to the public for anybody to access. So it's good that it's only accessible from our local machine. What we need to give Stratus is a URL to allow it to connect to a MongoDB instance. And actually you can see when we've run the command line Mongo client, MongoSH, it's actually given us this URL up here. We don't need all of this. I suppose we can copy all of these sort of things. App name we probably don't need. Direct connection equals true, server selection. Let's just try copying just the start, so the actual IP address and port number. So we'll copy that. We're going to exit out of this for a minute. Now Stratus is going to look for that. If we look, let's do a list. Let's look in databases, MongoDB, MongoDB.cpp. So this is the place in my code where we're establishing a connection to the database. And what we're doing is we're loading the URL from a file called MongoDB secret. The reason that we're doing that is because rather than hard coding database credentials, username and password into my source code, which is a bad idea because you can accidentally put it in version control and expose it to the entire world, what I'm doing is putting credentials for the database into this separate file, MongoDB secret, and then that's just read at runtime by the code. And that file is set up to never be put into Git. So we want to take this URL and we want to put it in a file called MongoDB-secret. So MongoDB secret, and we can pop in our URL there. All right, now hopefully we are set up to connect to the local MongoDB instance, which is now running. The last thing that we need to do is we need to create a database in MongoDB called Agape. And at the very least, we actually need to set up an account for ourselves. So to allow Stratus to know that there is somebody who is allowed to connect. So we're going to go back into MongoSH. We're going to go use Agape. So that will switch to a new database, which is called Agape. Now we have to actually set up a user. Okay, so in the microsystem, there's a concept in which a user can be authenticated to the server, generally, but then also a device can be authenticated. So one user might have multiple devices, they might own multiple computers. So the user has a secret key that they use to authenticate to the server, but then each device also has a secret key. So we're going to have to actually set up at least one user key and one device key in the database so that we can actually have our client connect. Now, generating account keys and device keys is usually done through a web interface for the cloud system that you would be connecting to if you bought a Microsystem 1 kit. I haven't released that source code yet, I may do, but I will probably come up with a command line tool soon that will allow you to actually generate these for your own local testing. But for now, I'm just going to actually plug in a sort of key that I've already generated prior. And there we go, that seems to have worked. So now let's exit out of this, and you'll be pleased to know we're going to now compile the client, but that's much easier to compile because it has fewer dependencies. We will need to install Qt though. Qt is the windowing library that we use to actually allow us to draw stuff onto the screen and to receive keyboard events. So let's go to, this is called Terminal Simulator, the client that runs on your machine. I guess it's called that because the idea originally being that the actual hardware thing, this is a real terminal, whereas Terminal Simulator is kind of like the code that would run on that machine, but running on your local computer. Okay, so let's install Qt. Qt 6 is the latest, but I'm not sure whether this version of Debian still only has Qt 5. We should have Qt 6. There's a lot of different Qt 6 packages to work out how we actually install the base system. So apt install Qt 6. You can have base dev. Let's give it a go. So what's it going to want to install? A bunch of libqt6 stuff. That looks good. Let's say yes, and also qmake6, which is the make system which we need. Have another drink. Okay, so now we need to go ahead and do qmake, which I think is qmake6, to distinguish it from the previous version of Qt, which is Qt 5. So if we go qmake6, Okay, so we have a can't find WebSockets. Do we need to install WebSockets? Cache search, qt6 grep WebSockets. Yes, we do. We can install qt6 WebSockets dev. Let's do it. So when we do qmake, it's actually working on this file, which is terminalsimulator.pro. So we have a look at that file. So a pro file is kind of like a make file. Well, it's kind of like the thing that makes the make file. So it actually has sort of the different source files that we're going to compile into the program, the headers. So let's do qmake 6. Okay, so now you'll see that we do have a make file. So we can go make-j4, and it's compiling. Okay, something has gone wrong. Usually when we're doing make with -j, sometimes because it's making a lot of things in parallel, if there is an error, it goes off the top of the screen. It might be make more sense if we just do make on its own. So there we go. If we make one thing at a time, then we're going to actually see the error, because as soon as there's a failure, we're going to stop immediately. So as part of Terminal Simulator, it's got the ability to play back MIDI, so sound files, through the ALSA sound system in Linux. So we're going to need to install, I think it's lib.A-sound, the development library. So install lib.A-sound to dev. And let's try again. There we go. Perfect. Finished. Let's see if it runs. Ah, fantastic. So I have to explain a few options in terms of Terminal Simulator. By default, so it's started up in a mode where we have pixel art turned off. So what that means is that in the usual way that maybe we need to go back a step here. All of the graphics in the microsystem are based on the sort of VGA fonts from the original IBM PC. And in fact, it's a thing called code page 437. Look at code page 437. So these are the characters here. And you'll notice how, with the drawing characters, maybe it's a little bit hard to see on this video. Maybe we can zoom in. But the drawing characters that use a series of some of the block drawing characters use a series of dots that are spaced out. The problem with that is that when we actually try to draw that onto a screen in a different resolution, it can look really weird. So I've got code in here that actually kind of turns this sort of dots, box drawing characters into solid colors. We also have the ability to change the zoom. So if we do Control 0, that will turn pixel art on. We have to restart to see the effect of that. You might see now that we actually have these discrete dots rather than solid colors. So you can turn that on and off depending on whether you like it or not. We'll probably turn it back off. You also have the ability to use Control- and Control+ to change the size. You're probably going to find that things are going to look a little bit weird if you're at a kind of non-integer scaling factor, so at 1.5. And in fact, if we do Control 9, that turns on some smoothing, but then the smoothing doesn't look so good. Let's turn that back off again. It's probably best to use integral scaling factors, so let's leave it back at scale of 2. So we're on the welcome page. This is the onboarding process, which is exactly what you would see if you bought the actual real hardware microsystem kit. So we're going to hit the ret key to continue. Now I'm going to enter the account key and device key that I created before. Like I said, there will be a tool that will generate account and device keys for you, and then you'll be able to actually put those into MongoDB and you'll know what words to plug in here. I need to still write that tool, but that will be coming soon. In the meantime, I'm going to put in something that I've cooked up earlier. So secret keys in the microsystem we use for authentication, which is proving to the server that we are who we say we are, and also for encryption, which is protecting our communications so that nobody else can read it. They're always 128-bit keys. The keys can be written in many different ways. One way to write them is instead of ones and zeros, although that's very hard for you to write out and remember and to communicate with other people. So what we do is we take a key, which is a sort of randomly generated series of ones and zeros, and we turn it into a series of English words, kind of like a big password. This is based on the way that Bitcoin does it for wallet addresses, which is called BIP39. I've taken their word list and slightly modified it. So I'm going to type in a key that I've cooked up before. You'll notice how we only have to type in the first 4 letters. So we type in the next word as a result, RESU, and then it will take us straight to the next field. That's accepted, and now the device key. In fact, the Agape word list is better than the BIP39 word list on which it's based. In the BIP39 word list, there are some 3-letter words, but when you type in 3 letters, it could be the 3-letter word you've just typed, or it might just be the first 3 letters of some longer word. That's not the case in the Agape word list. It's always the case that when you type in 4 letters, that uniquely identifies a word. And that's accepted. Now the Wi-Fi networks are faked up, so it doesn't matter what we select here. And we can enter any password. Hopefully this is not the password for your actual Wi-Fi network. Now, I think what that has done is it's connected to the actual real Agape server on the internet. We actually want to go and change this to connect to our local server. So if we hit Control Z, that will jump out of the onboarding process and it will mark the onboarding as being finished and done. So then that takes us straight to the main menu and we can go and tamper with things there. So if we go into the server, we will see that yes, it's added the real server. Let's get rid of that. And we can add our local server. WebSocket addresses that use TLS start with WSS for WebSocket Secure. We need to actually go and run Stratus to make sure it's running, so we can bring up another terminal. Get Stratus up and running. Go back into Terminal Simulator 127.0.0.1.8.4.4.3, and that's added. Now, there is a quirk currently in the code where if you've already connected to a server and it is already connected to the cloud server, we can't force it to disconnect and reconnect to a different server. This is a bug. So we're just going to close Terminal Simulator and start it again. As long as that server is the default server, then it will try to connect to that one on the next restart. So let's close this and we'll run Terminal Simulator again. And we're going to go Select World. When we go into the Select World screen, it's going to force it to try to connect. So we'll see whether connection works or not. Well, that hasn't worked. Okay. Connection failed. So I think the problem that we're having is when Terminal Simulator is trying to connect to Stratus, Stratus is presenting our self-signed certificate. In other words, a certificate that we've just generated ourselves, which is not verified by anybody. And Linux has an idea of who it will trust in terms of who can sign a certificate. Because we've generated one ourselves, it's not one that's known to Linux, and therefore we're getting this TLS error where it won't connect. So we can put our own certificate that we've generated into the Linux store so that it will know to trust ours. So I think that it is user local share CA certificates. Yep, so I think we can copy it into there. So cp stratus cert.pem to user local share CA certificates. Let's call it stratus.pem, so we'll remember where we generated it, where it came from. We need to do this with sudo, so let's do that. Okay. Now, I believe that there's also some kind of caching that goes on where all of the certificates are sitting out there in text format, but I guess they're cached or compiled into some kind of binary format somewhere. So we need to do sudo update CA certificates. 0 added, 0 removed. So that hasn't worked. Did it not pick it up from user local share CA? Let's try man update CA certificates. Okay, so user local share CA certificates with a .crt extension. So how about we go sudo mv for move user local share CA certificates stratus.pem to user local share CA certificate stratus.crt apps. Let's just look at the man page again. Let's run the command. 1 added. Okay. Let's try running this again then. Terminal simulator. And we're going to go into select world to force it to connect to the server. No, it still does not seem to have worked. So I think we may have made a mistake here. When we generated the certificate for Stratus, I think I put down the name for the certificate as being localhost, whereas here we've actually set it up as with the IP address 127.0.0.1. I think if we delete this and we put it back in as localhost, it may work. So let's give that a go. Let's go X for delete, and then we're going to add it again. Now this time we're going to go WSS://localhost 8443. Okay, and let's go into select world and see if it works. Yes, that has worked. Perfect. All right, so if we look in the terminal simulator debug output, we can see that it has connected. And let's go and have a look over on the Stratus side of things. Okay, now we are having an issue where it says no valid authentication. Terminal Simulator, the client, doesn't seem to be authenticating to Stratus, the server. And I think that's because of something in Terminal Simulator to tell it to only send keys to a particular list of servers which are trusted servers. This is so that we're not going and accidentally sending our secret authentication keys to just any old server that we might be trying to connect to. So let's see if that's the case. If we stop Terminal Simulator, let's see if we go. I believe it is phonebook.cpp. Right, okay, so, and again, I've got to fix me, should this be hard-coded or should be a user option? What we probably want to do is allow you to specify whether the server is one where you should be sending it your keys or not. We've got 127.0.0.1 in here, but we've just reconfigured to use localhost in the phone book because that's what we used in our SSL certificate, our TLS certificate. So why don't we just... in a minute. And again, editing with Nano is not exactly the best thing, but we'll see where it gets us. We really need to install a proper IDE in the next video, I think. localhost. So now we'll accept glina.com.au, which is the server that I'm running in the cloud, or localhost, or 127.0.0.1. And in all of those cases, we're going to send our keys. Let's see if that will work. Make, and run again. So what we're hoping to see is in the server output here for Stratus, we're hoping to see that we receive a key and that we actually recognize that key from the client. Let's give it a go. All right, so let's try connecting now. And we are connected. We'll bring up the Stratus window, and I think that's worked. We can now see our world list. Well, there's no worlds in the world list yet. However, if we look at the Stratus output, we should be able to see that we sent an authenticate message to the server. And the server was actually able to, it says authenticated successfully. It was able to actually find the device key and the account key in MongoDB. Perfect. So let's see whether we can create a world on our local server. We can use the arrow keys to choose which avatar we want, left and right to choose your avatar, and up and down for the color. I'm going to select this, I'm going to be a pink lady, why not? Maybe that's a bit cliched, but we'll go with that. All right, I am Lauren. And let's call my world Lauren's World, because I'm so imaginative. Okay, now it's going to give us a world key, which if we were going to want to bring in friends into our world, we'd want to share this world key with them. So again, this is probably not useful if we're just actually running this as a local test instance. However, I think what we're working toward is when you buy the Micro System 1 computer, I'm going to be running a version of Stratus in the cloud for you to make it convenient for you, so you can just actually buy the kit, put it together, and then start playing with your friends immediately. But if you want to run your own server, then you can, and you would do what we've just done. You would set up your own version of Stratus, and you would add users into your database, and then you would, create worlds and share the keys around. So let's just hit enter, or ret as I call it in Micro System World. There we go, let's see if we can get in, and we're in, perfect, it works. Although it is a field of question marks. Usually there would be grass and we could build objects, but in this case with Terminal Simulator we have no objects. So we have no artwork on the server at the moment. The server has no art, so let's try creating something. If we go Control E, and now the ground tile, so the thing that by default will be on every scene, even empty scenes, I think is called ground. So let's make it, that seems fine. How about we just go with a kind of a green? Let's go very boring. Oh, that's not green, that's a solid block. We want to choose the foreground color by going Control up and down. And let's go RRRRR. And we can save ourselves some time by using copy and paste. So let's just go, I'm holding down Shift and I'm using the arrow keys. I'll go Control C. Now I'll move the cursor and go Control V. And we're going to save that with Control S. Hey, there we go. We created a ground tile. Although it's a very boring ground tile. So thank you for joining me for what's been a bit of a long video, but hopefully this will give you some idea about how to set up the Stratus server on your own machine and how to set up your own local client. And that'll put you in good standing for watching future videos where we'll go through how the software works. Maybe we might tackle some bugs together, and you'll be able to actually have that set up and be able to try to work along on your own local instance. I hope to see you in the next video. I think that we'll do the marshmallows and we'll do the hot chocolate again, and maybe next time we might tackle a bug. Thanks for watching. Bye for now. The certificate and the private key are used as part of asynchronous cryptography between the client and the server. The certificate, asynchronous.